Many common electrical circuits are controlled by time delay relays. Their purpose is to delay the power up or power down of electronic components following a specific interval of time. The delayed dimming of an interior overhead light after a car door has been closed, or the temporary running of a fan to cool a video projector after the bulb has been turned off, are two examples of time-delayed relay operations. Let's look at four basic types of relays. There are two types of relay functions: on delay and off delay, each with two types of contacts, normally open and normally closed, represented here by four symbols. NOTC functions as an on delay with normally open contacts. NCTO operates as an on delay with normally closed contacts. NOTO functions as an off delay with normally open contacts. And NCTC operates as an off delay with normally closed contacts. First, we have the normally open, timed closed NOTC contact. This type of contact is normally open when the coil is unpowered or de-energized. After the coil has been continuously powered for a specified amount of time, in this example 5 seconds, the contact is closed. The contacts will immediately open when the coil is de-energized. Next, we have the normally open, timed open contact. Similar to the normally open, timed closed contact, this type of contact is normally open when the coil is unpowered or de-energized, and closed by the application of power to the relay coil. However, unlike the NOTC contact, the timing action occurs after the coil is de-energized for 5 seconds. Thus, the contacts close immediately when the coil is energized and open 5 seconds after the coil is de-energized. Next, we have the normally closed, timed open contact. This type of contact is normally closed when the coil is unpowered or de-energized. The contact is opened with the application of power to the relay coil, but only after the coil has been continuously powered for the specified amount of time, in this case 5 seconds. Thus, the contacts open 5 seconds after the coil is energized and closes immediately when the coil is de-energized. The last time delay relay we will look at employs a normally closed, timed closed contact. Similar to the normally closed, timed open contact, this type of contact is normally closed when the coil is de-energized and open by the application of power to the relay coil. However, unlike the NCTO contact, the timing action occurs when the coil is de-energized instead of when it is energized. Thus, the contacts open immediately when the coil is energized and close 5 seconds after the coil is de-energized. Let's look at a common application of a normally open, timed open relay in the operation of a video projector. In this circuit, closing switch S1 turns on the projector bulb and activates timer coil TR1. With timer TR1 energized, normally open contact TR1 immediately closes, energizing the fan motor, which controls the cooling of the projector. The projector bulb and the cooling fan remain on as long as switch S1 stays closed. When switch S1 is opened, the projector bulb turns off and power is removed from the timer. Contacts TR1 remain closed for a preset period of time and then open, causing the cooling fan to turn off. This off-delay timed open circuit is generally set to adequately cool the projector equipment before it shuts off.
Young English Engineer. Your way to the electronics world. Like our Facebook page and learn more. Project provided by Tesla Institute. School of Electrical Engineering and Automation.